Last year, while I was traveling to join our bunch, the Blue Ridge Singers on tour, this year college boy asked me if I want to ride. I allowed as how I did, and I got in. Pretty soon we come to what they call a throughway, which is a road you got to pay to ride on. They gave us a ticket when we got on, which read on the front, Syracuse 9 a.m. And then we really took off down that throughway like a pair of scared rabbits. That speedometer went up and up, and I saw them mile markers keep a-passing. Well, friends, I see a sign saying it's a Buffalo exit, and off we go. But before the college boy could even pay, the ticket taker, he hands his ticket to the police, and the police ups and says, "You've been a-speeding. You've been 150 miles in 2 hours. So someplace you've been going 75 miles an hour." Well, the college boy, he tries to lie out of it. But the police, he says, "Don't they teach you calculus at that college you go to?" The boy, he says he flunked it last year and is taking it again, but he don't like it a bit. Well, the police says you better learn some. We'll just draw a graph of this here problem we got here. We draw vertical and horizontal lines. We measure time horizontal and distance from New York vertical. Time he calls T, and distance from New York F of T. Then he ups and puts numbers on these lines. He calls them axes, and he marks up 2 numbers real plain on what he calls the T-axis. Now, the police says, at 9 o'clock, we were 280 miles from New York. So we'll just plot a point here and call it 9-280. And he ups and says, at 11 o'clock, you come here to Buffalo, which is 430 miles from New York. So he puts this other point down and calls it 11-430. Well, you know, he draws a little curved line between these points and says this is pretty close to the graph of that function F. He says this curve has a height that's how far from New York you are at any time T. Then he draws these 2 lines and says one is how long it took, 11 minus 9, and the other is how far you come, which is 430 minus 280. And so somewhere we had a speed of 430 minus 280 over 11 minus 9, which is 75 miles an hour. He calls this F prime of C. Well, friends, this college boy tried to agree with him, thinking he might get out of a fine that way. But the police, he says, if the college boy had been driving correct, he wouldn't be here till noon, no way. So he says, we'll just learn you some calculus now. So the police, he says, if A and B any times on your trip, F of A will be how far from New York you are at time A, and F of B will be how far from New York you are at time B. Now, says he, I claim the quotient F of B minus F of A divided by B minus A is your actual speed at least once from time T equals A to time T equals B. We already know speed is the derivative of the distance function. Well, friends, it seems to me as how the college kid had had enough, but the police, he don't quit. He says, more generally, you ought to know for what kind of functions this is okay. Let's look at the graph of a function again. We'll take a look at 2 points on it, A, F of A, and B, F of B. We can draw a line through these points, and this line is the graph of some linear function. Now, he claims, this here line has a constant slope, and he even writes a formula for it. But, he says, he just don't know for sure about the slope of this here curve. But maybe somewhere between A and B, the slope of the curve is the same as the slope of the straight line. Then he writes what maybe is the slope of this curve for this point. Now, the police, he don't let up. He asks the kid if he knows the mean value theorem. The kid, he says you got to learn it by Monday. Well, says the police, we'll just write it down right here and prove it. If f prime exists on open AB, and if f is continuous on closed AB, then for some c on open AB, f prime of c is f of b minus f of a over b minus a. Now the police goes on. A, f of A is one point in the graph, and B, f of B is another point. And here we got a line through these 2 points. Now the police, he claims this here line is the graph of some linear function, which he calls L. And what's more, he says, a linear function has a constant derivative, and he writes down that formula for it again. Now, says he, remember, we got 2 functions. The height of the curve is f of x, and the height of the straight line is L of x. And the difference of these 2 heights is f of x minus L of x. We can even get the graph of this new function, f minus L. By the way, he says to the college kid, you ever hear of Rolle's theorem? The boy, he says, sure. I memorized that last week. Well, the police says, we want this here new function to satisfy the conditions of Rolle's theorem. First, we see that f minus L is 0 for x equal to A. Then we see it's 0 for x equal to B. We see it vanishes A and B even easier if we look at the graph of f minus L. Now, says he, f is continuous on closed AB. We know, too, L is continuous on closed AB, because L is continuous everywhere. So, says the police, a difference f minus L is continuous on closed AB. What's more, he says, f has a derivative on open AB, and L has a derivative on open AB. If both have derivatives, the difference f minus L has a derivative on open AB. Now the police, he smacks his lips and says, you see, this difference function vanishes at A and B, is continuous on closed AB, and is differentiable on open AB. So, according to Rolle's theorem, as any idiot can plainly see, this f minus L prime will be 0 somewhere on open AB. Now, friends, you know what this police did then? He puts all these here graphs on one sheet of paper, and he draws little tangent lines to them, and he says that the difference between the slope of f and the slope of L is the slope of this here f minus L. He names these f prime, L prime, and f minus L prime. He says that when f minus L prime is 0, f prime has to equal L prime. And since f minus L prime is 0 at C, f prime equals L prime at C. But since we have L prime of X equals F of B minus F of A over B minus A, we have F prime of C equals F of B minus F of A over B minus A. And this is a theorem of the mean. Then the police, he says to the college boy, before I let you go, maybe we better run through this again with another function. I'll just draw the graph of this one. So the college kid, he took the pencil and he says, where this graph cuts the lines X equals A and X equals to B, we get 2 points, and we draw a line between these 2 points. This line is the graph of a linear function L, which has a constant derivative. The difference between 2 functions is itself a function, and so we can draw its graph too. Since our first 2 functions are equal at A, a difference function is 0 at A. This is true at B too. Since our 2 functions are continuous on closed AB, a difference function is continuous on closed AB. Since our 2 functions are differentiable on open AB, a difference function is differentiable on open AB. The difference function satisfies conditions of Rolle's theorem. So for at least one value on open AB, call it C1, the derivative of F minus L will vanish. Maybe the difference derivative will vanish at another point. Call it C2. At any point where F minus L prime vanishes, F prime will equal L prime. So, if F minus L prime of C1 is 0, F prime of C1 equals L prime of C1. And if F minus L prime vanishes again at C2, then F prime will equal L prime at C2. But the derivative of a linear function is a constant, equaling the slope of the line, which is the graph of the linear function. Thus we have that our function F has a derivative which at one or more places on open AB equals F of B minus F of A over B minus A, and that's the mean value theorem. Well now, folks, what you allow the police done then? He just told the college boy to go on home and study his calculus. But what I want to know is just what chance has a college kid got with these here educated police all around, even if he does get himself a jazzy convertible.